Unbound local error on local variable when reassigned after first use. The following code works as expected in both Python 2.5 and 3.0. However, when I uncomment line B, I get an unbound local error column C not assigned at line A. The values of A and B are printed correctly. I don't understand. Why is there a runtime error raised at line A, because of a later statement on line B? Why are variables A and B printed as expected, while print C raises an error? The only explanation I can come up with is that the assignment C plus equals 1 creates a local variable C, which takes precedence over the global C. But how can a variable steal scope before it exists? Why is C apparently local here? See also using global variables in a function for questions that are simply about how to reassign a global variable from within a function, and is it possible to modify variable in Python that is an outer, but not global, scope? For reassigning from an enclosing function, closure. See why isn't the global keyword needed to access a global variable? For cases where op expected an error but didn't get one, from simply accessing a global without the global keyword.
Python treats variables in functions differently depending on whether you assign values to them from inside or outside the function. If a variable is assigned within a function, it is treated by default as a local variable. Therefore, when you uncomment the line, you are trying to reference the local variable C before any value has been assigned to it. If you want the variable C to refer to the global C equals 3 assigned before the function, put as the first line of the function. As for Python 3, there is now that you can use to refer to the nearest enclosing function scope that has a C variable.
Python is a little weird in that it keeps everything in the dictionary for the various scopes. The original A, B, C are in the uppermost scope and so in that uppermost dictionary. The function has its own dictionary. When you reach the print A and print B statements, there's nothing by that name in the dictionary, so Python looks up the list and finds them in the global dictionary. Now we get to C plus equals 1, which is, of course, equivalent to C equals C plus 1. When Python scans that line, it says aha, there's a variable named C, I'll put it into my local scope dictionary. Then when it goes looking for a value for C for the C on the right hand side of the assignment, it finds its local variable named C, which has no value yet, and so throws the error. The statement global C mentioned above simply tells the parser that it uses the C from the global scope and so doesn't need a new one. The reason it says there's an issue on the line it does is because it is effectively looking for the names before it tries to generate code, and so in some sense doesn't think it's really doing that line yet. I'd argue that is a usability bug, but it's generally a good practice to just learn not to take a compiler's messages too seriously. If it's any comfort, I spent probably a day digging and experimenting with this same issue before I found something Guido had written about the dictionaries that explained everything. Update, see comments. It doesn't scan the code twice, but it does scan the code in 2 phases, lexing and parsing. Consider how the parse of this line of code works. The lexer reads the source text and breaks it into lexemes, the smallest components of the grammar. So when it hits the line, it breaks it up into something like the parser eventually wants to make this into a parse tree and execute it, but since it's an assignment, before it does, it looks for the name C in the local dictionary, doesn't see it, and inserts it in the dictionary, marking it as uninitialized. In a fully compiled language, it would just go into the symbol table and wait for the parse, but since it won't have the luxury of a second pass, the lexer does a little extra work to make life easier later on. Only, then it sees the operator, sees that the rules say if you have an operator plus equals the left-hand side must have been initialized and says whoops. The point here is that it hasn't really started the parse of the line yet. This is all happening sort of preparatory to the actual parse, so the line counter hasn't advanced to the next line. Thus when it signals the error, it still thinks it's on the previous line. As I say, you could argue it's a usability bug, but it's actually a fairly common thing. Some compilers are more honest about it and say error on or around line 30, but this one doesn't.
Taking a look at the disassembly may clarify what is happening. As you can see, the bytecode for accessing A is load_fast, and for B, load_global. This is because the compiler has identified that A is assigned to within the function, and classified it as a local variable. The access mechanism for locals is fundamentally different for globals. They are statically assigned an offset in the frames variables table, meaning lookup is a quick index, rather than the more expensive dict lookuppers for globals. Because of this, Python is reading the printer line as get the value of local variable A held in slot 0, and print it, and when it detects that this variable is still uninitialized, raises an exception.
Python has rather interesting behavior when you try traditional global variable semantics. I don't remember the details, but you can read the value of a variable declared in global scope just fine, but if you want to modify it, you have to use the global keyword. Try changing test to this. Also, the reason you are getting this error is because you can also declare a new variable inside that function with the same name as a global one, and it would be completely separate. The interpreter thinks you are trying to make a new variable in this scope called C and modify it all in one operation, which isn't allowed in Python because this new C wasn't initialized.
The best example that makes it clear is when calling foo. This also raises UnboundLocalError, although we will never reach to line bar equals 0, so logically local variable should never be created. The mystery lies in Python is an interpreted language, and the declaration of the function foo is interpreted as a single statement, i.e. a compound statement. It just interprets it dumbly and creates local and global scopes. So bar is recognized in local scope before execution. For more examples like this, read this post, this URL. This post provides a complete description and analysis of the Python scoping of variables.